So with object-oriented programming, what it's all building towards and the really key feature, the integral feature that makes object-oriented programming work as well as it does is polymorphism. Polymorphism actually comes from the Greek meaning many shapes. And so basically a single class can take on many shapes. In order to do that, we do have to have a class hierarchy with inheritance. That is part of why we discussed that first. And so you've got to have a superclass with multiple subclasses. You've got to have a parent class with many child classes. And the idea is that the superclass can take on the form of any one of its subclasses. So the superclass can kind of have many shapes, which are all examples of the overall class. Now, in order to really run with this concept, we're going to talk about something called a virtual function. And a virtual function basically takes on a different shape depending on the child class that it is within. So the kind of funny thing about this idea of a virtual function is you might define a function first in your parent class, and then you'll actually use the function in the child class. And depending on which child is using it, the child may use that function in a different way. So as an example, kind of, or an analogy, we could have a general class called vehicle, and then the vehicle class could have subclasses. You could have cars, SUVs, and trucks. And so if you have an operation, like you're going to buy a chair from the store or something, each of your vehicles could carry the chair. With a truck, you would just put it in the bed. Probably strapping it down would be a good idea. Just saying. You might tie it to the roof of a car, or if you have an SUV, you might have one of those dealies where you gotta it has fold-up seats where you can collapse it and have a flat bed in the back of your SUV. And then once it's converted that way, you can carry the chair inside of it. And so the big idea is you have a generic class vehicle, and you would have an operation you want to do like carry chair. And then the implementation of carry chair, like a function essentially, depending on which vehicle it is, the implementation of how you would carry that chair is different. Either you're going to stow the seats, put it in the bed, tie it to the roof, but it's the same action. Inheritance has the advantage that it does save coding time, but there's an even bigger advantage to inheritance, which is that it allows you to have polymorphism. Inheritance isn't just like a convenience thing. I guess it is a convenience thing, but it gives you added functionality by having polymorphism. So if you use a function in a class, every descendant class can use that function. You could have a superclass animal. You could have subclasses like zebra, elephant, and giraffe. So we could have a function that takes an animal as its parameter. And so in the computer's mind, animal is a generic class. And if you give it specific instances, if you give a function that does something with animals, like, I don't know, ride them. I don't know. I gather riding zebras is not, but apparently the reason why they didn't domesticate zebras, even though they're just like horses, is zebras are vicious jerks who will bite you if you get anywhere near them, which is why the Asians and Europeans had horses and why the sub-Saharan African cultures were not riding around with like cavalry units on zebras. Just FYI. Anyway, the process doesn't work in reverse. So like if I have an animal, I can pass to it a zebra. However, if I have a zebra, I can't pass to it animal. So it doesn't work where, it only works where the child can use the parent class, but the parent class can't use the child class. So let's look at a program here, shall we? So let's move this code over to Visual Studio. Okay, so here we've got this is similar to the last set of examples. So we've got a generic class called product. It's got a cost, a wholesale cost, and a retail cost. We've got a function to calculate the profit we make, which is just the retail cost minus the wholesale cost. We've got a subclass plate, which draws from the class product. It has an additional feature or member variable, the diameter of the plate. We have a subclass for cup. It draws from product. It's got a number saying what its volume is, and it has a string for what its color is. The subclass cup has its own subclasses. So these would be like, I guess, the grandchildren, you could say, of the original product class. So here, and the cup has children, plate does not have children. And if the product class is like any grandparents I know, they're kind of getting on plate's case for like, hey, how come you haven't had any children yet? Your sibling cup has children. When are you ever going to settle down? Anyway, I'm getting a little too elaborate with my metaphors. So what we got? We have a subclass called measuring cup. It's drawing from cup. Yes or no, is it in metric or not? We have a number of gradations, so the little tick marks on the measuring cup. Think of like a beaker in a science class or something. Let's see here. We've got another class for drinking cup, and it just has a Boolean, yes or no, does it have a lid? Then here we've got this float sale price. So this is a function. So what this does is we have the retail cost. That's what we're going to charge people to buy our products. And what we're doing in this program is we're making a new function that will basically apply a 10% discount to our products. So, that's something that people in a store would want. Yes, they do sales sometimes. 10% off is a pretty standard discount. I don't think I've seen something like 38% off or 23% off. That's not really a thing. It could be if you wanted to dare to be different. So what do we have? We have a function here. It outputs a float. What goes into the function named sale price is a product. So any kind of product, either a generic product, a plate, a cup, specific cups like measuring cups or drinking cups, anything that is a product, which is essentially everything, can be fed into this function. And so we're going to just call it some generic product P. Here's what the function does. It returns, you take P, call whatever product you gave it, find the retail cost of it, and multiply it by 0.9. Because fun fact, if you pay 90% of the value, that means you've taken off 10%. So anyway, in the main program, we're making a measuring cup called plastic cup. We're going to set its cost to 0.10, its retail sale price to 0.30, or the price we sell it for. Here we have a coffee cup, which is a drinking cup. We've got its wholesale cost and its resale cost. And then here, what we're going to do, here we go. So the sale prices will be, we're going to do the function sale price of plastic cup. We're going to do the sale price of coffee cup. And so if we run this, it will basically tell us the original prices of these products, as well as the discounted prices of these products. And so again, the big takeaway here we have inheritance, and we have a function that can call any type of object that is from the parent class. So we can feed members of subclasses or child classes of that parent to that function. And so it's going to churn out its stuff here any day now. So the coffee cup costs 8 cents and so okay, so the coffee cup sells for 40 cents, the plastic cup sells for 30 cents. The sale prices are going to be 27 and 36 respectively. So those are 10% discounts applied to 30 cents and 40 cents. Those are some cheap cups, I got to say. Anyway, all right, so that is that example here. So really, this is not quite polymorphism. This is just kind of seeing how you can take a function that you can pass children to a function where the function takes in the parent. And so if it takes in any product, you can use a product, a plate, a cup, or a drinking cup, or a measuring cup. You can do any kind of cup.